Now, before I start, I kind of want to get a feel for where this audience is. I'm guessing, looking out here, that you guys are fairly familiar with the NSEC. Can you raise your hands if you're comfortable with it, you understand it, kind of? Okay. What about RPKI? Okay. I'm going to try to fly over a brief tutorial I have on DNSSEC and maybe focus a little bit more on RPKI. All right. Let's see here. DNS and BGP were both developed back in the 80s. And this is when the internet was a different beast. Security was a little not quite as important as it is today, or the threats weren't the same. From today's point of view, they are not considered very secure, but methods for securing them do exist. Starting with DNSSEC. DNS Name System Security Extensions. The design of it started in 1993. The root zone was signed July 15th, 2010, and it's still not completely deployed, though it's really got a lot of momentum now, I think. It's designed to verify data integrity and authenticity. It is not some way of hiding your data. It just makes sure that the recursive name servers out there get the information that your authenticated servers, your authoritative servers meant to send. It exists on top of DNS. There were a bunch, 6 records that were added to support it. And it uses public key cryptography and the chain of trust that's similar to X509 certificates. The 6 records, DNS key, DS, RRSIG, NSEC, NSEC3, NSEC param, and eDNS was also developed alongside of it. This is basic overview of what the different keys are for. DNS keys are where the public keys are stored. They exist at the apex of a zone. There are 2 different kinds, generally, of DNSSEC keys: key signing keys and zone signing keys. We'll get into that later, maybe. The DS records, this is important. These are important. These are used to transfer trust from a parent zone to a child zone. I'll explain that a little more later. Our SIG records, these are the signatures of each RR set within a zone. Only one RR SIG record exists for every names RR set. They do not exist, as it says here, for NS records that delegate and glue records, since even though they exist in a zone, that zone is not authoritative for those records. And let's see, DNS key RR SIGs are signed by the key signing key. All other RR SIGs are signed by the zone signing key, generally. They don't have to be. And then NSEC records and NSEC3, and supporting NSEC3, the NSEC param records, they're used to prove non-existence. I believe that the phrase I heard earlier was at Schumann's DNSSEC tutorial, was authenticated denial of existence. I like the phrase. All right, a simple example. You would never do this by hand unless you're masochistic. But you have 10 records in here. Securing a zone, you generate the DNS keys, you add NSEC records to point to the next secure area to cover the gaps between your records, so that if there is a query for a record that doesn't exist, you can prove that to the recursive name server that record does not exist, or that R type doesn't exist. Once again, NSEC does not do glue. And as is obvious in this little example, it's easy to enumerate a zone with NSEC records. NSEC 3 exists to sort of make that difficult. They hash the next secure record. And yeah, it can also be used to opt out of signing parts of zones. Then, once the NSECs are in, you add the RR-SIGs. Obviously, this really blows up the zone from something like that to that. Once again, every name's RR set has an RR-SIG. And then the delegation, in this example, I have sub.example.com is delegated to another name server. And so we put the DS record in there to point to the key signing key of the sub.example.com zone. And then the RR-SIG gets added, the NSEC record gets updated. Okay. So we've got all this data in the zones. We're publishing it. But that doesn't do any good if no one uses it. The idea is to have validating recursive name servers. And response validation involves following this chain of trust down from wherever your trust anchor or anchors lie. These days, it, for the most part, can be the root key signing key, down to the zone and the record that you're interested in, or the NSEC. The backbone of this chain of trust is the DS, DS key, and RR-SIG interaction. The trust travels from your secure entry points down to the target name. This is a very simplistic description of it. You choose the root KSK is your trust anchor. You use that to verify your DNSSEC RR-SIGs. If you verify that, you trust the ZSK. The ZSK signs the DS RR-SIG. Once you trust that, you can get the child zone's KSK, hash it, make sure that the DS record in the parent zone matches the hash of the child zone KSK. You trust that, and then just wash, rinse, repeat all the way down. Once the target child zone is found, then you can use the ZSK to verify the appropriate RR-SIG or NSEC RR set. If the question can't, right here, if the question can't be answered, then you present the NSEC record. And this is wrong, actually. If the answer can't be verified, then I believe serve fail is returned, not annex domain. So I need to update that. All right. From a publisher's point of view, you have a lot more data in your zone files, and your responses are bigger to queries, and you usually have more responses involved in a basic lookup. This can lead to problems. One of the problems that I think a lot of name server operators saw earlier in the year was using DNS-enabled authoritative name servers for amplification attacks. But there are ways around it. But it's something you need to be aware of. Management of the keys can be tricky. Key rollover can be a challenge based on what software you're using. And if it's not done right, it can lead to your DNS disappearing from the network, at least for validating name servers. Once again, it protects the data, but it doesn't protect the headers in your DNS responses, so that if someone was doing something nasty with your packets, with your responses, you wouldn't know, as long as the DS records and the RR-SIGs and all that, the DNS key records are untouched. And it does nothing to protect the communication between the stub resolver and the recursive resolver. There are ideas for securing this, but there's DNSSEC doesn't have anything to do with that. At ARIN, we currently sign our v4/8s and our v6/12 and our /24s. The ARIN online interface that our members have access to allows you to update your DS records and put them in the parent zone, whatever that might be based on your IP resource, along with your NS records. Here's these first two links, DNSSEC Analyzer and DNSViz, I found to be really useful in learning DNSSEC. VeriSign Labs, and I think the second one's Sandia National Labs. LDNS Drill, another nice command line tools and libraries. DNSSEC Validators, an interesting little Firefox plugin. And this, at the bottom, is a link to a whole bunch of other tools. And that was DNSSEC. That was pretty quick. Okay, RPKI. This is a little more confusing. All right, the Interdomain Routing Protocol, BGP, was created when the internet environment had not yet reached the present contentious state. I like that phrase. Consequently, BGP design did not include protections against deliberate or accidental errors that could cause disruptions of routing behavior. It's from RFC 4272 from, geez, almost 7 years ago now. There are still a lot of security issues related to the internet routing fabric. As the phrase goes, and I've heard it used a lot, BGP is essentially routing by rumor. This guy down here says, hey, I have 209.85.128/17, and it tells its upstream, and then its upstreams tell other people, and it passes along all the way throughout the mesh. And then suddenly the guy on the upper left says, I need to send a packet to your .100 host. And it takes a look at its routing and gets a path from green to yellow to purple, or magenta, or whatever that color is. And so it has a path like this, through AS100, AS200 to AS300. But then along comes AS666 and says, hey, I have a highly preferred route to 209.85.128/17. AS200 sees that, says, I'm going to send it to AS666. And suddenly, for at least some of the network, you are offline. Some examples of this, and these were just a few. April 1997, AS7007 announced paths for all the internet to themselves. And I don't think that lasted too long. September 24, 2008, Pakistan Telecom announced part of YouTube's address blocks. April 2010, China Telecom misoriginated some of the internet blocks affecting iRoute. And just last month, Google was unavailable in some places by a route leak from Moratel. In all of these cases, as far as I've heard, these were all mistakes. They were not done in any nefarious ways, but it still affected a good chunk of the internet. And this can happen again, and probably will happen many more times. To secure the internet routing fabric, it'll take two phases, generally. Origin validation, and then path validation. Origin validation can be done today with RPKI. The second part, path validation, there's still a lot of, they're still in draft phases. But hopefully, RPKI will be part of that solution. So what is RPKI? RPKI is Resource Public Key Infrastructure. It takes the ASNs and the net blocks that are allocated, combines them with a public key, and signs them. They use X509 v3 certs with RFC 3779 extensions to wrap this all together in a well-known format. And every resource holder can request certification, and it passes down from RIR down to ISP, to maybe another sub-ISP, to some other endpoint. As an example, here is generally a very simplistic example of the resource allocation hierarchy. IANA allocates a whole bunch of resources to the various RIRs. RIRs, in return, allocate some of those resources to other members. For RPKI, we sort of mimic that, except for the fact that right now, IANA is not signing anything. So each RIR is their own trust anchor. Each RIR has a self-signed cert at the top, and it covers all of our resources. Obviously, if we have a little more than 192/8. One of our members, say ISP1, requests that we certify their resources. We sign their certificate. The certificate has their resources in there. And one of their customers, ISP3, requests that they sign it. So we have this hierarchy of resources, but it doesn't bias anything when it comes to origin authorization. The whole key of this is the route origin authorization, or the ROA. All of RPKI exists to support this. What this does, well, let me give an example. Here we've got this resource hierarchy. ISP3 says, I only want ASN 123 to originate my /24. And because of the format of the file that the ROA is published as, it has an N entity cert that is signed by, well, the ROA is signed by the N entity cert, and then the N entity cert is signed by ISP3's actual cert. But you can follow this chain all the way up to the ARIN trust anchor, but it could just as easily be all the way up to APNICs, RIPEs, LACNICs, AFRINICs. But it's a way to cryptographically validate that ISP3 only wants their network traffic to come from ASN 123. If they wanted to maybe multi-home and say, well, my network traffic can come from also ASN 321, they would just publish a second ROA that would also validate. All right, there are two different implementation types. One is delegated. That's pretty much what I explained just there. The other is hosted. Hosted, well, in effect, it is also what I showed previously, but instead of the various members being the CAs and doing the signing, and controlling the public and private keys, it's hosted at some level. Right now, either the RIR or maybe later on some level further down. And they manage all the keys for all the resources below them. All right, for most participants, running a CA would be a challenge, and it would undermine it would make it difficult for them to actually be publishing their ROAs. And we want to get ROAs out there. We want to get them announced and be available to everyone. And if you can avoid setting up a CA and still have a secure infrastructure, this is a good thing. And that's why hosted exists, and that is why ARIN first offered the hosted option. That's why, excuse me, ARIN's first RPKI offering was hosted, not delegated. Either way, either delegated or hosted, the RPKI repository is published. And the way you find out where the repository is, you get that RAR's TAL, or Trust Anchor Locator. The TAL consists of two parts. One is the rsync entry point into the repo, and the second is the public key of that repo. Reliant third parties out there that want to do these origin validation, they go out, they get all the TALs, download all the repos, and validate the whole structure. This is something that does not need to be done in real time. It can be done ahead of time. You can stage it, get it set on a server, and then once we have all these validated ROAs, what do? We use them to weight BGP and path announcements as they come in to your gateway routers. So using this example earlier, if the resource holder for 209.85.127/17 were to publish a ROA that said only AS300 can originate my 209.85.128.24 network space, the ROAs do not have to line up exactly with the assignments that that resource holder has. They can slice it up as far down as they want. So it's announcing its ROA, and then along comes AS666, and if AS200 is doing origin validation, they can sufficiently lower the preference of the route to AS666 or completely ignore it, depending on what their local routing policy is, or their local, routing policy is. And AS666 won't be able to hijack or accidentally take the traffic for at least 209.85.128/24. The border routers that will talk with this offline validating server using the RPKI router protocol. Currently, it's still in draft form, but Cisco iOS and Quagga have implementations of the draft form. Junos has recently added support for this, but I don't believe it's available out of the box. There may be others, I don't know. And if you know of others, please let me know. All right, offload validation and origin evaluation happens on some outside box or boxes that you have. The border routers send the origin to these validation boxes, and they reply with valid, invalid, or unknown. What happens on the routers is really up to your local policy. You can choose to increase the priority or the preference of routes that are considered valid. You can choose to decrease the priority of routes that are considered invalid, or even drop invalid. You can just ignore or not touch routes that are unknown. These days, most are unknown, but I'm sure that everyone's going to start publishing ROAs, and that won't be the problem anymore. Okay. As with DNSSEC, the more buy-in, the better the security. If nobody's doing this, there's going to be no incentive to actually have your border routers checking the RPKI database, and it doesn't bias anything if no one's using the data that's published. The more people that have their resources certified, or even better, are publishing ROAs, overall, the better the security. Really cool if you could validate route origins as your hardware or software support allows. Right now at ARIN, hosted is the only model that we currently implement. We will soon be offering delegated, probably in the next month or two. One of the requirements, actually two requirements that we've been given, are that we must have non-repudiation and that third parties need to sign an RPA, a reliant, not sign, but agree to a reliant party agreement before they get the TAL for ARIN, they get ARIN's TAL. The non-repudiation requirement is interesting. The idea is that even though we're hosted and all the key management is done on our systems, we want to make sure that nobody at ARIN can publish your ROAs, sign your ROAs without your okay. So when you get resources certified with ARIN, you submit a public key to us. What we do is we store your public key along with the private key and the another public key that are generated, another key pair that's generated on our HSMs. Whenever you submit a ROA to us, it needs to be signed by the private key associated with the public key that you submitted to us. We take that signed information, and along with your organization identifier, pump it into the HSM. The HSM validates the ROA that you submitted to us, and then we'll sign it with the public and private key that it had stored there. We do not have direct access to it. This is a way for us to know and for you to be sure that nobody on the inside at ARIN can mess with your ROAs. And then back to the RPA thing. Yeah, that's a requirement that the board put on us. Future for RPKI. Hopefully at some point it would be great if we could get IANA to sign everything so we have a single TAL. There are discussions, I'm told, between the RIRs and IANA about this, but I don't know the status of them. Inter-RIR transfers is a bit of a challenge right now. Every RIR has their own their RPKI process, and to try to get them working just right as the trust anchor changes, I think the phrase I heard is it's a delicate dance. And then finally, the whole goal of this is to have a secure internet infrastructure. RPKI is the first step of that. Hopefully at some point it could be integrated into a path validation system, but we don't know yet what it is. Questions? Okay. Richard?
Yeah, I've got a question.
Sure.
So I think ARIN just started doing started their RPKI services recently. It was just like a couple months ago?
Yeah.
Yeah.
Yep. September, I think.
Do you have any data on how many people have come in and decided to certify their resources? Is it just been a small trickle, a small handful of them, or are you starting to see a good number of registrants come in and certify their resources?
The number I heard is kind of old.
Yeah.
So I'm not sure. I think this was, at least a month ago I had heard like 24.
Okay.
Hopefully there's many more now.
So those are folks that did it right after you released the service, that came in and did it immediately. I mean, somebody's not going to come in and casually certify their resources using RPKI. It's not a casual thing to do that. I mean, you actually have to, want to go in and do that. So they're obviously waiting for you guys to do that.
Yep.
any data on how much traffic the other RARs are getting with their
I'm not aware
authorities?
of it.
Okay, all right. So is there any information that we've gotten from the community about why they would want to go use RPKI? I think I know why I would want to go use that, but I had heard some conversations going on around this that initially with RPKI, operators perhaps aren't thinking about the end game where they're better securing the routing infrastructure. They're more worried about certifying their quote-unquote ownership of their IPv4 resources using this process, because it seems like a more valuable assertion of their authority over that registration record than a simple answer in who is. Perhaps are we going to see some traffic that way at the very start? You heard much talk about that?
No, I have not.
Okay. All right. So, anybody have some questions about DNSSEC or RPKI from ARIN?
Hi, so one question about the RPKI to router implementation. So you had a slide where you mentioned implementations from these vendors, and
Yes.
Juniper is not quite there yet in production code. Does that imply that Cisco iOS does have production code? And if so, can you elaborate, and where is their documentation about it?
Actually, I found good documentation on it on the RIPE site. They
Okay.
have pointers to how to do this in Cisco iOS, how to do this in Quagga, and how to do it in Junos.
Okay.
The real differentiator up there was just that iOS, they're releasing excuse me, versions of iOS with the support built into it, whereas from what I understand, Junos, you need to go out of your way to get this implemented locally, to have this code available. I don't know how they do that. I'm unfamiliar with Junos, but this is what I'm told.
Okay. And is there any? Sorry about that. Is there any news about any of the other router vendors? Are they doing anything in this space, or do they have any plans you can share?
Not that I'm aware of.
Okay.
Sorry.
Thanks.
I'd like to ask if you're at a microphone, please identify yourself with the mic for the remote attendees.
Oh, gee, Richard, you beat me to it. I was going to say, I'm Jim Galvin, and I don't know who those other, anonymous people were in front of me. Not even this guy, Richard, who thinks he's running this thing. Two comments. First, you explicitly made the statement that RPKI is the first step to securing the internet infrastructure, and I'm hoping you dropped a word in that. Didn't you mean to say securing the routing infrastructure?
Yes, yes.
Okay, just wanted to clarify for the long-term record here.
Yeah, that would be a grand plan there. But no, just the routing infrastructure.
But no, my real question is, others have talked about this, and so I'm wondering if you could speak directly to this question here for the record about keeping statistics on the value, and well, both keeping them and publishing them, making them available about the value of RPKI. In particular, even if you choose to ignore the results of the validation, you should be keeping logs about, well, I would have done this, or I could have done this, this route could have been dropped, and that kind of thing, just to look and see whether or not you're actually improving things or not as it begins to deploy further. And I'm wondering if you would be doing that in your use of it in particular?
I always recommend you record data. My background is in statistics, so I love data. Yeah, I don't have any recommendation one way or the other right now.
I mean, is ARIN going to do that as far as its routing that it does for itself? I realize you're not a major hub of traffic, I suppose, so it might be more interesting from others, but
I think it would be a very interesting idea, but this is not my decision to make.
okay, thank you.
Yes.
Hey, it's Rick Lamb from ICANN, and this is a question in my personal capacity. I'm asking you this also in your personal capacity. You personally, do you think RPKI is it? There's not going to be some other mechanism out there that they'll use to validate routes? I mean, I've heard some people trying to use the inat or not arbitrary, and I of course have my own prejudices and views or stuff like that. But I was just from an operator's point of view. I mean, RPKI is pretty baked in at this point, right? This is what we're all going to do.
It seems out of any of the plans that seems to have the most momentum right now.
Okay.
Who knows? I mean, there's always other ideas out there.
All right. You got any thoughts about some of the other? I think it's pretty old. It's been stuff discussed in the ITF, 10 years ago, just using DNS to actually try to. And I'm not proposing that. I think that's kind of odd. But
yeah, I mean, DNS has been suggested for supporting all kinds of systems, and I think it's to some degree a bit of a religious discussion,
yeah.
Whether or not it should be used for that. The reality is RPKI is available now. All the RIRs support it. It seems to have momentum.
Okay, cool. Thank you.
Yep.
I can't reach the mic. I have a question from Twitter from NBK1. He says, is there any update on creating a public listing of DNSSEC supporting registrars at ICANN and or per each TLD's NIC?
I have no idea. Is anyone else can answer that?
Yeah, Rick.
Well, this is Rick Lamb from ICANN again. Yeah, we do have I could do a better job, but we do have a public list of registrars supporting DNSSEC, and the difficulty here is we want the registrars they have to come to us and give us their information, and then we'll put it up there. But I'm sure at some point in this talk we'll mention it, and there's actually others that actually keep track of these things as well. So we do have such a list.
Thank you.
So this is Jim Galvin again. I mean, I'll observe that I know registries that have tried to keep this list, and what's interesting is, and others have tried to go out and find out whether they do it. From our side, at Affiliates, I work with Affiliates, and so we're a registry service provider. So in one dimension, we know whether or not a registrar is able to support DNSSEC because we obligate them to test through it. But we don't keep lists that we don't publish, because what's interesting is there's a real distinction between whether or not they offer the service or have the ability to offer the service. And it's a self-selected kind of thing right now. There's one of the registries that we host, PIR for .org, actually maintains a list on their website of all of those registrars that have passed the OT&E testing. But that doesn't necessarily mean you can get the service and buy it. So I think the ICANN list is really the one at the moment which is best, because it's self-selected, so people are clearly saying they offer it. But it's a difficult thing. There are just too many registrars to go out and check them all.
And if you can, vote with your wallet. Go with the registrars that do support it.
Yeah, this is Dan York from the Internet Society, and I'll just sort of close off on that answer, Megan, that you got out there too. What Rick said, ICANN's been keeping this list up, which is great. We've had some info up on our Deploy 360 site, some tutorials walking through some of those that are there too as well. But I mean, hopefully, eventually we'd like these lists to go away, because ultimately we'd like to have all of the registrars just supporting this in some way, shape, or form, maybe some directly, maybe some less. And that'll be a question certainly we'll be talking about in the panel coming up after the break. This will be one of those questions, is how do we get more registrars looking at this? So if the person out on Twitter, if they're listening to the live stream, if they'll watch this when we come back from the break, we'll have that as part of the discussion that's going on here as well. I guess on going back to the secure routing, the RPKI piece of this, does ARIN have plans to help promote this within folks? I mean, promote the use of RPKI? Are you developing, information or materials around this to help promote the use of that?
Yeah, our communications department is working on all kinds of documentation for supporting this. I believe at our member meetings we have at least one session on RPKI, what it is, how to use it, and whatnot. We are pushing it, yes.
Sam Gillespie with Drexel University. I'm just curious, with the major issue of routing delays currently on the internet, does RPKI add any extra burden to the current delays that are already being experienced?
It shouldn't. The RPKI router protocol, the lookups, should be to boxes that are topologically close to these routers. And it's a matter of, is this origin valid? And since all the cryptography, all the expensive computation has been done ahead of time, it should be a simple lookup in a database and a quick response back. So I guess there is a little extra delay, but hopefully it would be marginal.
All right. Well, excellent. Well, I'm coming back to the microphone to say that I think it's wonderful that we have the future of the internet being IPv6, DNSSEC, and we want better routing security on the internet. And as far as I know, from your presentation, I know ARIN is, but all 5 regional internet registries are there and working with us, and they've made sure that their part is done. For the RARs, we've got reverse DNS. NADR.ARPA is all set for DNSSEC. We've got RPKI set up and ready to use at the RARs. They've been registering IPv6 for over 10 years. So the RARs are future-proof. They're there for us. I think that's wonderful. So I want to thank Pete very much for coming and presenting today and letting us know.
You're welcome. Thanks for having me.